Several. Blue? Several. Maroon? Just you, okay? So I would say that we kind of have a representative sample. Again, not scientific, okay, but just throwing it out there. So I don't know what you have. I'm going to take 5 of you. You tell me what you have. That's my sample. Then I'm going to see. Then I'm going to look at your color of your notebook. Okay. So I see what you're doing here. But what you could do is actually use any of these for your variable. Okay. So how many people in here have a college ruled notebook? How many have a 3-subject ruled, 3-subject notebook? How many have a specific color? How many have a specific size? Okay, how many have pockets in your notebook? How many have bound versus spiral? Thank you. How many have college ruled versus wide ruled? Okay, we can narrow down the characteristics, and maybe it's something that's very interesting because I work at a school supply company. Okay, and I want to know, well, in college, what's the most popular type of spacing, line spacing, okay? Is college ruled really used more in college or not? Okay, so there could be a very good purpose for using this type of statistic, okay? Okay, any questions? Great. Okay, so 2 major types of statistics. All right, these are kind of like, you can't get more broad than this. Right? So we have descriptive and inferential statistics. These are two statistics, types of statistics that we're going to be covering this semester. So can somebody tell me, just give a guess, what a descriptive statistic, either an example of one or kind of like a sort of like a definition or a phrase that would describe it? Descriptive statistic.
Would it be like color or something like that, like with a notebook?
Yeah, sure. Right. So like, okay. So yeah, it's like a color. So a certain characteristic. Okay. That we'll talk more about that when we talk about scales of measurement on Thursday. But sure, you know, we can describe something with colors. Okay. But let's talk about values. Let's talk about quantitative values. So or descriptions. So descriptive statistics. What do descriptive statistics do?
Describe.
They describe. Okay. What do they describe?
A sample.
They describe either sample or population, if we know anything about the population. And what are some examples of a descriptive statistic?
I think I have an example. So would it be like, for example, if we were to like measure everybody's height in the room and we say like, oh, 40% of people are like this height or higher?
Sure, I mean percentages are great, right? Because I don't have to go and measure all of you, but if I'm presenting this to someone, I don't have to say, this person is this height, this person is this height, this person is this height 50 times. I can say 40%. And isn't that nicer just to hear that, know what that means, and be able to interpret that, instead of me giving you all of these data that doesn't mean a lot to you and it takes up a lot of time to read through. Instead, I have summarized it for you using a percentage. Okay? What other value could be used to describe statistics? I'm sorry, describe variables.
Well, isn't it like a procedure that just is like a summary of simplified data?
It is. It's a summary. We're going to summarize it. Okay. We're going to simplify the data and organize the data. Okay. So that would be actually the definition. We're going to summarize, organize, and simplify the data. Okay. Instead of getting all of this data, we're going to. Measuring all of these data, we're going to just give you one value that sort of summarizes it all. So, somebody give me examples of statistics. I'm sorry, of descriptive statistics. What are some things that we do or values that we use, we talk about percentages, that summarize, organize, and simplify data? So it makes us easier to interpret.
Averages?
Yeah, averages, definitely averages. In fact, that should be the first thing that comes to mind because our average or mean is really fundamental to all of the stats we're going to run. So the mean. What other value might help us to summarize a bunch of data? Just make it smaller. Yeah.
The mean?
Yeah, sure.
The most.
Naturally comes after, sure. These measures of central tendency, of course. If I wanted to compare how you guys do on tests to my other group, then I would most likely get an average or a mean. Okay. I wouldn't compare one of you to one other person. Each of you to a person doesn't make sense. So compare the whole group. What else? Descriptive stats.
Standard deviation?
Sure. Okay. I want to know the range. I want to know how far apart your scores are from the mean. Because you guys could score a 50, if they could score a 50, right? But you guys, if you guys had a really small range around 50, then you would have a very different, you would have performed differently than if they had a large number around 50, okay? What else?
Number of scores?
Yeah. Number of scores, sure. That definitely describes. It may not necessarily organize or summarize, okay, but it means that we don't have to count it all up. Well, I guess it does summarize, right? So you don't have to count each score, we can just provide an N. How about pictures, visual? What kinds of things, visually speaking, would help summarize data? Let's see someone who hasn't spoken yet today.
Graphs?
Graphs, of course, yeah, graphs. Charts. Maps. Okay.
Dot plots?
What was that?
Dot plots?
Oh, sure. Sure. So all these different types of graphs, you guys have used them in different math classes, but beyond that, you see them all the time. What about a weather map? Has anyone seen a weather map before? Yeah. So say in Seattle right now, it's probably raining. So what so you might see a map on the news about showing how much rainfall they're getting in different parts of Seattle, okay, or maybe even Washington, the whole state. So a map is really good because instead of going around and saying, okay, in this square, mile, this is how much rain they're getting. In this square mile, this is how much rain. Wouldn't that be annoying? In every square mile of the whole state of Washington, you would have a number about how much rain, okay, there's going to be. Instead, we average those together, okay, not we, but meteorologists will put those together. So you can say in this region, this is how much rain. In this region, this is how much rain, not in this little piece of the state, okay? So we're taking an average so that you don't have to use your brain so much and exhaust your brain looking at every single piece of data, okay? All right, so, yeah. So these are pretty much everything that you said, so that's great. Then inferential stats. Okay, so inferential stats. What's the base word of inferential? Infer, okay. So we're not coming up with a exact answer. We're not proving anything. We're inferring something from the data that we have, okay, and that's techniques that we're using to find that. So inferential stats, techniques allow us to study samples and then make generalizations about the populations from which they were selected. Oh, that's starting to sound really familiar, okay? So when we've been talking about samples and populations, we've been talking about inferential stats. A third of the class will be looking at descriptive statistics, okay? And the other 2/3 of the class will be focusing on inferential statistics. And usually when you hear the word statistics, you're thinking about inferential stats. So we have 3 tests, right? The first test is over descriptive stats. The last 2 will be over inferential stats, okay? So you have an idea already of